Hello students, welcome back to my channel once again. So today we will be discussing the CBSE board grade 10, the first chapter, that is real numbers. This is going to be the part 7 video. So already I have discussed previous parts in 6 videos. I have split it into 6 videos. So if you haven't watched that, please watch that first, then come back to this video. Okay, here we will be solving some problems based on the fundamental arithmetic. Okay, and also we will do some problems using the HCF and LCM. So now let's dive into the problems. So let us take a look at the first question. The question is, check whether 6 to the power n can end with the digit 0 for any natural number n. Okay, so here we have to check whether 6 to the power n, is it possible to have 0 at the end with the digit 0 means it should 0 should be in the unit place of the number. So let us check how we are going to solve this, how we can prove whether it is possible or not. Okay. Sorry for my bad throat. Okay, so end with the digit 0 means it can be represented in the forms like which is a multiple of 10. So like 10, 20, 30 like this. Okay, so now we have to check 6 to the power n whether we can represent it with the multiple of 10 or not. So we know that whenever we end with 0 means it should be a multiple of 10. So that means the numbers, because we know that the factors of 10 are 2 and 5. So if the unit digit or the if it should be end with 0, then it will always be divisible by 5, because end with 0 means multiple of 10. So that means the number should be always divisible by 5. So now we are going to check whether 6 to the power n has any factors of 5 or not. Okay. So if the number 6 to the power n for any n belongs to n, that is the natural number. Capital N means the natural number. Ends with the digit 0 or not. So then it should be divisible by 5. Okay. So that means the prime factorization of 6 to the power n must contain the prime number 5. So if we can see that 6 to the power n should have a will have a prime number when we factorize it, if we get a prime number as 5, then there is a chances that it will end with 0. Now let's see whether there is any prime number 5 present or not. So 6 to the power n means 6 into 6 into 6, that is 6 multiplied by n times, right? So now 6 to the power n means 6 means what? 2 into 3. So that is, we can represent 6 as 2 into 3. So 6 to the power n as 2 into 3 into 2 into 3 into 2 into 3, and this keeps on going for n times. So here 2 and 3, you can clearly see these are the prime numbers. So here we have never got the number 5 over here, right? So in this case, it is not possible to get the prime number 5. So that's why this is not possible, because the primes in the prime factorization of 6 to the power n are 2 and 3. So by fundamental theorem of arithmetic, there are no other prime numbers except 2 and 3 in the factorization of 6 to the power n. So there is no natural number for which 6 to the power n ends with the digit 0. So whenever it should end with a digit 0, there has to be a prime factor, that is 5. So which is missing, that's why it is not possible. Now let's move to the next problem. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So composite numbers, what we need to understand? Composite numbers are those numbers which can be expressed in terms of product of primes. Like 4, 6. Okay, that means which are not primes. Those are composite numbers where we have more than two factors. We know that in prime numbers we have only two factors, that is the 1 and the number itself. Composite numbers are those numbers which have more than two factors, that is 1 and the number itself. Other than that, there should be another factor. So that is the composite number. So now let's see whether we are getting more than two factors or not. So in the first expression, 7 into 11 into 13 plus 11, 13 plus 13. Now if we take 13 is common over here, then 7 into 11 plus 1. So 13, so 77 plus 1. So that means 13 into 78. Now 78 we can represent as 13 into 2 into 3. So here we can see that these are the product of prime numbers. Okay. So that's why this is a composite number, because here there are, if you can see, there are multiple prime numbers. It is a product of multiple prime numbers. So that's why it is a composite number. Now let's take a look at the next expression. Next thing, that is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. So we can clearly see that 5 is common over here. So let's take 5 common. Then 7 into 6 into 4 into 3 into 2 plus 1. Now if we calculate 5 into 1008 plus 1, that is 5 into 1009. So here it is also the product of primes. So since we got product of prime means, here whenever a composite number has a product of prime numbers, okay, then we can represent it as a composite number. So this is also a composite number. Now next question. There are 156, 208 and 260 students in groups A, B and C respectively. Buses are to be hired to take them for a field trip. Find minimum number of buses to be hired if the same number of students be accommodated in each bus. Okay. So what we need to find over here, what is given, that there are some students which is grouped into 3 groups. Okay. And for them to take to the field trip, different buses have been hired, and we have to find the minimum number of buses so that they have, in each bus there will be same number of students. So the number of buses will be minimum if each bus accommodated maximum number of students, isn't it? So then only the number of buses will be minimum. If we can accommodate the maximum number of students in each bus, then the number of buses will be the minimum. So the number of students in each bus, since it will be the maximum number of students, means we know that whenever we need to find the maximum of something, then that should be the highest common factor, that is the HCF. So the number of students in each bus must be HCF of the student numbers, that is 156, 208 and 260. So now let's do the prime factorization. So 156 means, let's do the prime factorization over here. So that is 2 square into 3 into 30. Now 208, let us do the prime factorization. So that is 2 to the power 4 into 13. Now let's do 260. So which is coming 2 to the power 2 into 5 into 30. Okay, so HCF, we know that HCF is we have to take the common prime numbers and the minimum power. Okay, so here 2 to the power 2 is the minimum one. 3 we can't take, 5 also we can't take. 13 is common between all the numbers, so we can take 13. So that means 4 into 13, that is 52. So in each bus, 52 students can be accommodated. So now, but that is not the question. They are asking that how many buses will be required, minimum number of buses. So minimum number of buses will be required for, that will be, since each bus will have 52 students, first we need to calculate the total number of students. So total number of students divided by the number of students in each bus, that is 52. So total number of students is 156 plus 208 plus 260 by 52. So now do the addition. So 624 by 52, that is 18 buses. So this is going to be the final answer. So the 18 number of buses will be hired if the same number of students can be accommodated in each bus. Now next question is mason has to fit a bathroom with square marble tiles of largest possible size. The size of the bathroom is 10 feet by 8 feet. What would be the size in inches of the tile required that has to be cut, and how many such tiles are required? So what is given? The bathroom size is given. So a bathroom that has to be fitted with marble tiles of largest possible. So each marble size should be the largest, the maximum one. So what would be the size of the tile required and how many tiles required? Okay, these two parts. So the length of the bathroom is given 10 feet by 8 feet. So 10 feet by 8 feet, let us do this in the form of inches. So we know that 1 feet equal to 12 inch. Okay, so 10 feet equal to 10 into 12, that is 120 inches. Now breadth of the bathroom is 8 feet. So that means 8 into 12, that is equal to 96 inches. So now the area, because here we have to fit in the floor, right? Fit the marble tiles in the floor. So that means we have to consider the area of the bathroom. Okay. So because that area in should be divided into different marble size, right? So now the area of the bathroom is the length into breadth. So 120 into 96. Now here the total area is 120 into 96 is given. But they are asking that what would be the size in inches of the tile required that has to be cut. So that means if we can find the highest common factor of length and breadth, okay, then we can, that should be the maximum size. Because if we can find the highest factor between these two, then the number of tiles will be required also minimum, and the high size of the tile will be the maximum. So let us find the highest common factor of length and breadth. Okay. So now do the Euclid's division algorithm over here. So 96 divide 120 by 96. Now 24 is the remainder. Now 24 will become the divisor and 96 will become the dividend. I hope you remember this Euclid's division. So now there is no remainder. So 24 will be the HCF over here. Okay. So if we write it in the Euclid's division algorithm, so 120 equal to 96 into 1 plus 24, then 96 equal to 24 into 4 plus 0. Since we got remainder as 0 over here, so the divisor will be the HCF. Okay. So now HCF of this length and breadth is 24. Right. So the side of the tile is, so here since it will be the square marble, so one side will be, each side will be 24 inches. Okay. So the area of the tile will be side square, that is 24 into 24. So which is, no, now we will not do the calculation. Why we will not do the calculation? Because after that, when we find the total number of tiles required, for that if we just divide it, we can easily cut those parts. Okay, so that's why we are not doing the multiplication for now. So total area of the bathroom is 120 into 96 by 24 into 24. Now we can easily cut this 24 with 120, that is 5, 24 and 96 4. So now that's why always try to do the multiplication or division, whatever, that at the end. Okay, so this will help you to cut the numbers. And if you do the mistake in doing the multiplication, then your marks will be gone. No? So that's why always try to do at the end. So we got 20 non-marks. Okay, so what will be the size of in inches of the tile required? That is 24 into 24. Okay, so tiles, that will be the size. Since they are not asking, sorry, they are not asking the area. If they are asking for the area, then it will be 24 into 24. But since they are asking for the size in inches of the tile, so that means one size, one side of the square tile. So that is only 24 inches. And the number of tiles required is 20. So that's all for today. Thanks for watching this video. If you like this video, please hit the like button. And if you have anything to comment, you can always put that in the comment section. Please share this video with your friends. And to get the upcoming videos notification, for that you just need to subscribe to my channel. For that, just press the bell icon. Okay, that's all for today. Thank you.